Hey, where's your ribbon? Oh, I don't wear it. You don't wear the ribbon? Aren't you against AIDS? Yeah, I'm against AIDS. I'm organized. Just don't wear the ribbon.
Who do you think you are?
Put the ribbon on. Hey, Sid, Bob, this guy won't wear a ribbon. Who? Who doesn't want to wear the ribbon?
Do you think you're sponge-worthy?
Yes, I think I'm sponge-worthy. I think I'm very sponge-worthy.
Run down your case for me again.
Well, we've gone out several times. We obviously have good rapport. I own a very profitable electronics distributing firm. I eat well. I exercise. Blood tests matter. And if I can speak frankly, I'm actually quite good at it.
You gonna do something about your sideburns?
Yeah, I told you. I'm gonna trim my sideburns.
The bathroom in your apartment?
Cleaned it this morning.
The sink, the tub, everything got cleaned?
Yeah.
All right, thank you, Kevin, and thanks for everyone in joining this. What I'm going to try to do, I usually don't mind questions during the middle of a talk, but maybe just to make this flow a little bit better, if you have a question, type one in to the chat, and then at the end of it, we can address the questions. And if you need to leave, you need to leave. I believe Kevin said the questions will be answered. So what we're going to try to do is cover several different topics today, mostly related to soil sampling and where our fertilizer recommendations come into play. So here's what I was asked to cover: how to collect a soil sample, how these recommendations are made, reading a soil test report, and that includes CEC and base saturation, nutrient removal, change in soil test values, nutrient deficiencies, and some of the digital tools available. So hopefully in an hour we can get over this. And what I'd like to do, I'm just going to shamelessly plug something. I'm going to try to start doing some little short videos instead of watching this whole thing. If you want to see how to take a soil sample, you can watch a 3-minute clip of this, and we'll post that on our CAT's web page. So moving on. So we want to collect a soil sample that represents the area of interest. There's 2 million pounds in an acre furrow slice of soil. Of that 2 million pounds per acre, so many of the samples are going to represent 10 acres or more. So we're looking at 20 million pounds. So of that 20 million pounds, about 1 teaspoon is used to analyze phosphorus, potassium, calcium, magnesium, zinc. 1 teaspoon. 1 tablespoon for pH and buffer pH. And I see Frank is on here. He can correct me if I get off on any of this. But we want to make sure that that soil that gets into the box really represents that soil well, or that sampled area well, because we're only using a real small percentage of that sample that actually goes to the box. So what we look for are uniformed areas. We base that on different drainage, cropping history, erosion, different things. A soil probe is best. You can use a shovel, but what we want to make sure that we're getting the same dimension or the same diameter of soil at 4 inches as we are at the surface. So if you use a shovel, you have to make sure to trim it evenly. But a soil probe is best. You can use an auger. That's not really well, that's a backbreaker, and you have some problems with getting the same amount. So we just want to make sure that that probe is representing that area well. Don't use galvanized buckets. Galvanized buckets contain zinc, so that can mess up your zinc result. This is really important for corn, especially in the bluegrass area where you have high soil test phosphorus. I like to air dry my samples before I send them. If possible, put them in the appropriate bag or box for shipping, but that's not necessary. So how much do we want that sample to represent? It really depends on the amount of variability, but we say no more than 10 to 20 acres. If you're submitting a 20-acre sample, that needs to be a pretty uniform field. So this is a picture of a farm that my parents bought about 20 years ago that joined up to the original home farm. You can see this is an old stock barn. Right here, this was a dairy barn where they milked. The cattle would loaf here. This is where they stalled before they'd milked. They'd worked their way over, go in and go out. So if I'm sampling this, this is roughly a 15-acre field. If I'm sampling this 15-acre field, it would be advantageous for me to not sample this blue area within the rest of the field, just because this had a high level of manure for a long time. And then guess what I did for about 6 years in a row in this area? I grew tobacco. So the rest of this was a hay field, and then this grew tobacco after being receiving a lot of dairy manure over time. So we want to separate this field out and make at least 2 samples for this area. The reason, another way to think about this is most likely going to have a lot higher soil fertility value than the rest of this field. So when we sample this, this is actually going to pull the rest of this field average up. So we'll be under fertilizing the remainder of that 11 acres, most likely, if we have some of the samples in here. This is some research that I started last year at the back of Princeton Station. Each of these squares represent a 10 by 40 block. So roughly there's a 1/4 acre here. Each of these numbers represent the soil test potassium, soil test K for each of those blocks. And I color coded them so you can see what kind of recommendations they would receive. We had one that tested 269, and it goes all the way down to 151, where we had a 90-pound recommendation. I'm going to explain this asterisk for a second. I think I got a bad sample. It tested at 784. So I included that in the average unknowingly, or I was in a hurry when we did that. So the average actually came up to a 207, which recommended 60 pounds of K2O per acre. If we drop that, the average is a little bit lower, and our recommendation would go up to 70. But for all disclosure, full disclosure, that's what's going on with this field. But you can see there's a fair amount of variability, but not a tremendous amount. So this is in a small area. Now let's ramp that up to a 20-acre field. Well, there's going to be more variability there. These are before any treatments were applied. This had been farmed for about 10 years. Well, not 10 years. The entire 10 years that I've been here, this was in production from the farm. So just quite a bit amount of variability within an area. So we want to best represent that. And what we do is take more cores. The more cores we have, the better. For the most part, we're going to get closer to the true average. So I'm going to just talk about random soil sampling today. Maybe later Josh can get on, or someone else I can talk about the different specific grid sampling or point. But anyway, this is just random soil sampling. We like to say a minimum of 10. There's some data that suggests we need at least 20 cores to represent that. Mix in a plastic bucket. So this is some pictures I took. Soil probe. I'm probing to 4 inches. This is no-till. I'm putting it in the plastic bucket. I like to mix it before I put it in a bag, and then put it in the bag and send it to the lab, send it to Frank or Amanda, and get your numbers back. So this is kind of a pictorial description of what I was talking about earlier, random soil sampling. This is a picture that I got from Josh McGrath. He was actually sampling poultry litter, but it worked out to be a good example of why we take more cores than fewer. So for this example, We're going to say this fella is 20 years old. He's 30. Josh was 40. This guy was 50. And this guy is 60. 20, 30, 40, 50, 60 to a total of 200 years divided by 5. The average age of that group is 40. Well, if I take one sample and it happens to be Josh, I represent the average age of that group well. But if I take any other sample, I'm off. So if I take this 20-year-old, I'm off by 20 years. Any additional sample I can take is going to get me closer to that true mean. 20 plus 30 is 25. 20 plus 40 is 30. 20 plus 60 is 40. So any time I take another sample, it's going to get me closer to the mean. That's just a mathematical expression. So utilize that when you're soil sampling. I'm not saying take 150 samples per acre, but I am saying that that's probably going to represent that acre a lot better than taking 1 per acre. So the more samples you can physically take and thoroughly mix in that bucket and get that sample into the bag, the better that sample is going to be represented in that field. So when do we sample? Is it in the fall or the spring? Really, that doesn't matter a whole lot. The more important thing is to do it the same time each year you sample and watch the trend. So if you sample in October or November, try to sample October and November each year. If you happen to sample in February, March, April, go on and try to do that. So you have trends you can compare. So this is some data that Murdoch generated in 2004, just looking at how seasonal, how soil tests fluctuate with time. So it looks like about every 2 weeks or so, took a soil sample. This dashed line is what they typically would see, but this solid line is what they saw in 2004 for pH. Now Frank has adjusted that. He does the KCL pH now, so that takes out some of the fluctuation that we have when you use UK Soil Test Lab for pH. We overwhelm that salt effect, so you get a better, more consistent pH than just the 1-to-1 waters, or 1-to-1 water pH that most labs use. Looking at potassium, starting at May, it starts to drop down. This is for in row and middle row middle. Either way, they're a little bit different, but the same trends. They drop down. This has been utilized by the crop, being still taken up. Start hitting this black layer. What's going on with the corn plant? Well, it's starting to senesce. Rain's washing the potassium out of the soil, or out of the plant into the soil, and then we have our maximum amount right around, first of the year. So that rainfall, I did some work when I first came. It looks like 4 or 5 inches of rain will get the majority of that potassium out of the plant back into the soil, so it can be captured in that soil test sample. Kind of see similar trends here with the phosphorus. It drops down and then kind of levels out over time. So just the big take-home message is soil test values do change over time, but the bigger issue is taking that sample at the same time, or generally the same time each year, so you're comparing apples to apples. So how often? That's really specific to the crop. The higher the value of the crop, the greater the removal. And we want to get more intense with our sampling. So the crops that come to my mind, high value crops, burley and dark tobacco. Alfalfa, that's a high value, high removal crop. Corn silage, small grain baleage, we're removing a lot of nutrients with that. Another crop that people don't think about as much are your hay fields. I know back in 2012, when commodity prices were real high, a lot of people were taking marginal fields out of hay production and put them into soybeans. Saw rampant soybean potash deficiency because people weren't staying on top of their soil fertility program with their hay fields. Oh, I'm going to add a little bit of nitrogen to green it up, maybe some lime every 6 to 8 years. I'm okay. Well, you're removing a lot of potassium. So just keep that in mind. The higher the value crop, the more intense sampling. So we'd say every year for these bottom ones, every 2 to 3 years for the other. You can take those samples or that sample. I'm going to grow wheat, or I'm going to grow corn, and I'm going to grow soybean full season each. Take that soil test value, take the recommendation for the corn, add it, take the recommendation for the soybean, add it. So how deep? Well, that depends on tillage. For UK, we say 0 to 4 inches for no-till. No-till includes hay fields or fields that aren't disturbed, and then 6 inches to or the depth of tillage for tilled fields. So this was a little something I did for a CATS training, or did some for some training we did not too long ago. I just wanted to see how much soil test depth really mattered. Did it really influence our soil test results? So I had 2 fields here at Princeton. One of them was a Kreider silt loam on the front side of the farm, for those of you familiar with Princeton, that's off of 91. And the other is a Zanesville silt loam on the back side. That's a fragipan soil. We had a corn soybean rotation and a corn wheat double crop soybean rotation. They were all both of the fields were no-till, and we had I collected soil samples in a 5 by 5 area. So this is a pretty small area. We expect very little difference between site 1 and site 2, but there could have been. I mean, I didn't really test that. I didn't test 1 core versus 2 cores, but what I did, I went in and I sampled 1 inch, 1 inch, 1 inch, 1 inch. I went around here and got about a half a bag of soil, taking 1 inch cores from each of the numbers. Then I went back to that same area, moved over, and took a 4 inch sample. 4 inch sample, 4 inch sample, 4 inch sample, 4 inch sample. Got my half a bag of soil. Then I took a 6 inch sample, 6 inch sample, 6 inch, 6 inch, and then did the same for 12. So I roughly got a half a bag of soil per each of my depths. Now, I took a lot more cores for the 1 inch than the 12 inch, and that's something, that could be discussed, but that's what I did. And here's what the data shows. For that Kreider silt loam, if I took a 1 inch sample, my soil test phosphorus was 151. As my sampling depth increased, my soil test phosphorus went down, 117, 92, 69. Soil test potassium, it's crazy high. At first I thought someone spilled a bag of muriate of potash in that area, but the field test high. I don't know what exactly went on before I took it over, but wow. But 975, 797, 674, 575. Same thing with zinc. It decreased with increasing soil depth. Well, didn't really see what I was wanting to see. I mean, I saw a difference, but when it comes down to management, is that really a management? Is there a difference in management that needs to occur across these soil depths? Not really. Now let's look at this Zanesville. My soil test phosphorus came back at 90 for that 1 inch, a 45 at the proper depth of 0 to 4, 32 at 0 to 6, and now 0 to 12 came back as a 15. So this matters. If I set my scout out, or if I'm taking soil samples that should be collected to a 4 inch depth, but they're not, now I'm saying I've got twice as much phosphorus out there as I truly do, and this is going to come back as a 0 recommendation. Now, with this example, we really don't expect to see a response. at a soil test value of 45. But if you can remember back to that little field where I intensively sampled, that's an average. So even though we don't expect a response at a 45, we're still going to make a recommendation. We have slop in our recommendations. One is to cover that variability, and two is to make sure that we aren't limited. Now, if we look at the 0 to 6 or the 0 to 12, now it's saying we have less. So our fertilizer recommendation is going to be a lot higher at if this 15 is represented, if we truly thought that was the correct sample depth. What about for soil test K? Well, at 252, we're probably in that non-responsive area, but we're going to still make a recommendation for your row crops. Now, is truly a 156 at the proper sample depth? Yeah, that's probably yield limiting. So if I think I've got 252, but I truly have 156, fertilizer dollars are tight this year, I think I'm going to not put potash down. I'll wait till next year. You're probably costing yourself some yield. So does it really matter? Yes and no. For this top field, the Kreider silt loam, it just happens to work out that regardless of the depth that we chose, all these values are above where we would make a recommendation. Our recommendation goes to 0 is the more correct way to say that. So from a management standpoint, it doesn't matter if it's a 151 or a 69 or a 975 or a 575. We're going to add 0. But there's not many fields that you're in that are going to represent this. This is more like it with this Zanesville. So we go from a 0 to 100-pound difference in P205, 30 to 100-pound difference in K2O. So that sample depth does matter. So if we say a 4-inch sample, you know, you need to be in that 4-inch range so we're truly representing what that field is, so we get the right amount of fertilizer on that field. So this is kind of wrapping it up. This is a nice slide that was put together. Soil sampling, we're in a no-till system here, 4-inch depth. I hope that previous example showed you that depth does matter. How often? More often is better for high-value crops. And you know, if a sample costs $7 and it represents 10 acres, that's 70 cents an acre. It's really hard to do anything else to your field. I know you have labor involved with that, but it's really hard to do you can't hardly do any other management operation for less than 70 cents an acre. So it's pretty cheap. So we want to make sure we're properly sampling, taking into account slope, drainage, and previous cropping history, and you know, the right amount of acres, no more than 20. Now I say if you go out there and you pretty intensively sample it and it's a uniform field and you can prove it, you can go over 20, but I'd say you need to do some legwork to test that before you do it. And for the amount of money that this costs, there's really no advantage. I mean, the more intense your sampling is, the better you can manage that field. So moving on, how much fertilizer do I add? And we soil test. That's what we've been talking about. Waters, A&L, UK, we all use a Malic 3 extractant. Now, some of the private labs, you can request other extractants. So if your clients are using Waters or A&L, make sure you know what extractant they are using, lost my word. Well, shoot. Anyway, what units are reporting in? I'm sorry about that, folks. So UK, we report in pounds per acre. A&L sometimes, and I've seen it from Waters, I believe, will report in parts per million. So they're not the same. Parts per million times 2 equals pounds per acre. So if I have a soil test value of 30 ppm, that's equivalent to 60 pounds per acre. But it doesn't matter which lab is doing this. This is a requirement for all of them. They need to be easily repeatable. They need to get that number multiple times from that sample. Need to get the sample in and get it out. And then we're talking about this value that we give our clientele needs to be equivalent to what is available for the plant. And this is what the land grants do that the big private labs rely on us for if they're using any calibration correlation data, is for this work to be done. So briefly, what we're doing with our extractant is we're trying to get at what that plant is going to see within a growing season. So we're getting the soil solution, we're getting the readily available fraction, and then maybe even part of this slowly available. So everything likes to be in equilibrium. So when you extract this, some of this pool is going to shift over, and then some of this over time is going to shift over. So what we're doing is trying to get an idea of how long or how much fertilizer is going to be available in a 15 or 20-minute lab extraction. I know many of y'all have seen this. I really like using this example, but it's kind of the same way. If this is a 5-gallon chicken waterer, I know I can get 5 gallons of water out of this for my chickens to drink. But if I take that and now make 3 gallons of ice and then start beating on the ice with a hammer, and I have little small chips that are going to melt before they hit the ground, and then I have chips the size of a marble, chips the size of a baseball, and some the size of a basketball. So I put my 3 gallons of busted up ice of various sizes back into there, and then I add 2 gallons of water. How much water do my chickens get to drink in a day? So it's going to depend on how fast that ice melts. So that's kind of the same thing that we're doing with this extraction. We're trying to give you an estimate in a very short time of what is going to be available to the plant. This is something Josh used that I really like. It's the iceberg approach. You only see a very small fraction of the iceberg floating out in the ocean. But when part of it comes off, more of it raises up to kind of, we're losing our weight, so that ice is going to be a little bit more buoyant. It's going to raise up. So the same kind of concept. We're just trying to get an idea of what's going to be available. Correlation, I know those of you that have seen me give talks see this just about at everyone, but it's really important. We want to know, is that extractant a good predictor of nutrient availability? So at this soil test value, I have this percentage of yield. As my soil test value increases, I have a higher percent of relative yield. And then at a certain point, I hit 95 to 100% of maximum yield. Well, that tells us, hey, this extractant is really relating back to my crop yield, but I need to know how much fertilizer to apply. So this was done over many different fields, different crops, different growing seasons to get an idea. Well, for this crop, if I'm in the low testing, I need to add this much to get up to yield. Well, I have more being provided by the soil. I'm higher up on this curve. I need to apply less fertilizer to get to that maximum amount. And then finally I reach a point where, hey, I've pretty much maxed out yield. We're going to say it's very unlikely that you're going to see a yield response at this level, so our recommendation goes to 0. This is another depiction of this. We have different soil test values. This soil test value was a 10. The orange one is a 20. The blue one is a 30. So you can see right off as soil test levels increase with no additional fertilizer, my yields increase. That's not a surprise. Same thing across all those lines with the different rates. If I add 50 on the low, I brought my yield up, but I didn't bring it up to where the 20 was yet. But when I get to the point I'm adding enough fertilizer, I'm maxing out. So at 100, I've maxed out all of it. So is there any reason for this initial soil test value of 30 to receive 100 if I maxed it out at 50? So that's what goes into the university. Almost all land-grant universities' fertilizer recommendations follow this same concept. This is a slide I put together to show a non-response. So it doesn't matter if I have 30 or 0 pounds or 120 pounds of nutrient, my response, my yield is the same. So this right here is what is keeping, this is one of the reasons that there's not good recommendations for sulfur in the southeast US. There's not enough responsive fields. This is especially true in Kentucky. I've been chasing the sulfur issue since I showed up here in 2010. There's just not enough responsive fields to do this kind of research in. And if you guys have some that you think of, please share with me. I'm sure Frank would like to get involved with this so we can give the clientele good information on how to make sulfur applications if they need it. But this is an example of a non-responsive field. So we soil tested, we've gone through correlation and calibration. Now, what tells me what rate I'm going to put down? So there's different philosophies, different approaches, different interpretations. So what the university uses is kind of a hybrid of all these, but I'm going to talk about it in general. A strict build-up or maintenance is regardless of what soil test value I'm at, I'm going to keep building. Now that's a silly approach, and I'll show you why in a few minutes, but build-up has its place. But if I'm in the central bluegrass and my soil test phosphorus starts at 420, is there really any reason for me to keep adding phosphorus fertilizer when my grandchildren's grandchildren probably can produce a crop of corn without adding phosphorus fertilizer because that soil is made from phosphatic limestone? So that buildup has a place, but not everywhere. Maintenance is, well, it doesn't really matter where I'm at. I'm going to replace whatever I remove. Well, there's a place for that, but in that same instance, if I'm at 420, do I need to stay at 420? When your soil test P hits 61, our recommendation goes to 0. So that 420 is seven times greater than where we expect to see a response. So the sufficient level of available nutrients, SLAN, this is our basic premise at the university. We're adding enough to satisfy that plant need. Well, depending on where we are, we might have a buildup component and a maintenance or just a maintenance. But we use kind of a hybrid approach of these three. This basic cation saturation ratio or nutrient balance, that is trying to fertilize the soil in an optimal cation ratio. This is a flawed approach. The guy that came up with this, Albrecht and Fred Bear, I think they eventually found out that it was wrong, but there are people that use this. You're going to be fertilizing generally more. Almost always you're going to have a higher fertilizer recommendation with this approach with no higher yields. And then, you know, other approaches, I'm going to shoot for a yield goal. We do not use yield goals in Kentucky. And this example is going to show you kind of why, I hope. So this is just a book value. It's pretty close to right, but corn removes about 0.4 of a pound of P2O5 per bushel of grain. So just doing the math, my 200 bushel corn crop is going to remove 80 pounds of P2O5 per acre. So if I'm going to maintain that level, that means I need to add 174 pounds of DAP every year, or every time I grow corn. Is that a good practice? So my question is, if we're going to follow this approach, why do we even soil test? So there's other things that should be considered. One, what is our initial soil test P value? So if we're removing this, hey, I've already got, 3 times the amount that is maximizing yield at this soil test P of 200. What about at 25? Well, you're going to need to add some at these lower soil test values. But do we want to just say, hey, I'm removing 80 pounds, therefore I need to add 174? No, it comes back to this buffer capacity. What is that soil providing? We can't account for that if we aren't soil testing. So even though we're removing 80 pounds, we might be getting 25 pounds released over the winter that is in this pool that the crop can utilize. So that's why soil testing is such an important practice. It gives us that current nutrient status of the soil, and those soils are changing over time. They are coming out of slowly available forms into readily available forms, into the forms that are taken up by the plant. So that measures that amount of the iceberg that we can see. Another thing, this is some old work that Bill Thumb and James Dollarhide did, but it's really interesting. So this shows the pounds of P2O5 that are required to change soil test P by 1 pound. So, and this is our initial soil test P value. If I'm at 50 pounds, my soil test P is 50 pounds per acre. Roughly, I have to add 5 pounds of P2O5 to change my soil test P by 1 unit. So if I'm at 50, I add 5 pounds, theoretically it goes up to 51. Now, if I'm down here closer to 5 pounds, I'm going to have to add 15 or 20 pounds of P2O5 to get a 1 unit change. If I'm on this other end, if I'm at 200 or 250, now it's like 2 to 3 pounds. So this soil test value, or this soil test result, is giving an idea of how much is being released from this soil. And in reverse, hey, I'm at a soil test P of 15, I added the recommended amount, but I didn't budget hardly any. Well, it's hard to build when you're at these low levels. And do you necessarily need to build it all the way up if you're adding enough for the crop every year? So that's a different conversation we can have at a different time. But anyway, for UT or UK soil test levels, with low testing soils, we expect a yield response, and we add large amounts. Medium test, we see small to none, but we add fertilizer to maintain that or slightly build that level, and to cover for that variability across the field. We want to make sure we aren't limiting. And then we don't expect a yield response when the soil test comes back at high, so we recommend 0. For row crops, that soil test P value is 61, and it's 301 for soil test K. I'm sorry, a typo there. Anything above 300, no fertilizer is recommended. Now for alfalfa and tobacco, we go up to 450 pounds of soil test K, and for tobacco, we go up to 60. But everything else is 61 and 301. So this is a conversation that started a while back, and I think it's a good exercise to go through. If I have to stop here after this, I feel like it was time well spent on this. So what does a soil test P of 30 mean for corn? So 30 pounds soil test P per acre. Does that mean I have 30 pounds of P2O5 that's available to the crop? Or does that mean I can take that 30 pounds and multiply it by 2.29 to convert phosphorus P to P2O5, and now I have 69 pounds of P2O5 available to the crop? Does it mean this is all I have? Once I remove 30 pounds of P2O5, my crop is finished growing. And does this mean if I follow AGR1, I believe them, I have 70 pounds of P2O5 per acre, which means I have to add 100, or I add 70 pounds of P2O5 per acre. So that adds up to 139 pounds of P2O5 if you're doing that math. And now I can grow 350 bushel corn before I run out of phosphorus. So I hope everyone knows that those are, very untrue statements. But a lot of people, it's a confusing concept. But a lot of people think, oh, it means if I don't have more than 30 pounds, all I can grow is whatever 4 divided into that is. No, that's not the case. So that means I have a soil test value of 30 pounds per acre. That's an index. That's giving me an idea, a relative idea of what I have compared to what, I need to maximize crop yield based on that calibration data. And that means based on AGR1, I should add 70 pounds of P2O5. That yield potential is determined by so many different management factors, not just the amount of fertilizer that's added. Just because I have this much 139 pounds of phosphorus now, that doesn't mean I'm guaranteed 348 bushels of corn. And that doesn't mean that I can't grow more than 348 bushels of corn with a lower soil test value. Our number one limiting production factor in Kentucky in dryland production is water. Water is the biggest driver. So there's a lot of other things that come into that. My 7th grade social studies teacher always told me you can't win the Kentucky Derby with a mule. Well, there's ground that's capable of making 300 bushel corn, and then there's ground that's not capable of making 120 bushel corn. So don't let this yield goal approach drive fertilizer recommendations, and be aware that this is a relative index. It is not an absolute amount. It's what we are measuring that is what we consider plant available during that growing season. So this is a soil test that Paula Howe made up for me before she left. It was a farm, she put my name on it, but this is what hopefully they're looking like. I know Frank has talked about changing the results some. I don't believe that has happened yet, but what we have here are our soil test P, our soil test K, pH and buffer pH, calcium, magnesium, and zinc. I really don't look at calcium because if you're keeping your pH right, you're in pretty good shape. If you're growing corn, pay attention to your zinc. But the important stuff is going to be listed down here. You put in what your primary crop, your management, what your previous crop is, and through AGR1, the recommendations contained in that publication, they're going to spit out recommendations for the crops you indicate. And then, the comments section, it talks about PK. Okay, this is how we determined it. Talks about our water versus salt pH. Even though we do a salt pH, we convert it back to water pH because that's what everyone's used to seeing. That's what I'm used to seeing. So if I get data back that's reported as a salt index, I convert it to a water just so I know what it is. And it talks about the different nitrogen applications. Now this box over here on the right, the calculated CEC data, calculated. That means it is estimated by what we get with our malic-3 extractant. So roughly it's it's plus or minus 2 to 3 milliequivalents from what the actual measured CEC would be. Does that matter? Sometimes it might. In 99.99% of the time for Kentucky agriculture, CEC is not really important because it does influence nutrient availability, that buffer capacity. It does influence our lime rate, but that malic-3 extractant gets a good handle on our P and our K. It also, the Sakura buffer, it does a good job of telling us how much we have, how much lime we need to add to change that pH to a desirable amount. So for the most part, I don't get hung up on CEC. I really don't get hung up on base saturation either. It can be usable very limited time, but for the most part, it's just window dressing in my mind. This is some work that Frank put together for a talk we gave a few years ago, 29,000 samples. Less than 1% had a CEC less than 10, and less than 14% had a CEC value greater than 19. So we have a very small range of CEC values in Kentucky. So that's another reason that the CEC really doesn't come into play. This is something just real basic and quick. How do we calculate? Okay, I've got my soil test results. I need to add so many pounds of P2O5 per acre. Okay, I'm using DAP. My recommendation is 70 pounds of P2O5 per acre. So for every 100 pounds of fertilizer, every 100 pounds of DAP, it contains 46 pounds of P2O5. So 70 divided by 0.46, I need 152 pounds of fertilizer per acre for this soil test value. Well, hey, I'm growing corn, so there's it's 1846.0, so 18 pounds for every 100 I have in nitrogen in that DAP. So 152, so every 100 pounds of fertilizer, I have 18 pounds of N. So I get roughly 30 pounds of N from my DAP. So these are just real basic fertilizer calculations. I'm about to get where I need to be. I'm going to move on, and we can talk about this at the end. But nutrient deficiency symptoms, I'd say the number one cause is low nutrient status of the soil. Those fields coming out of hay going into soybeans. I'm not soil sampling enough. I'm not adding the adequate amount of fertilizer. So that's probably, in my mind, one of the largest reasons we would see a nutrient deficiency symptom. But there's other issues as well. Poor, harsh environmental conditions. The most common example that comes to my mind is phosphorus in the spring with corn. We see that purple corn, the corn got planted, you know, the farmer's going to say April 1st so he can claim fertilizer or crop insurance, but truly it was the end of the third week of March. It turned cold, corn sprouted, it's not happy, it's not able to pick up the phosphorus that it needs. I'm showing phosphorus deficiency. Rooting issues. Maybe I have a wet environment. Maybe I have a compacted zone where the soil roots like sidewall compaction. Those roots are confined to a small area, so they have small soil volume to extract nutrients from. Disease or insect damage. If you have a rootworm eating on the roots, even though it looks like, hey, I've got decent roots. Well, maybe they're not able to function at full capability. And another one I didn't put up here because it's going to be the next topic, but I'm going to mention it, is low pH. You get your pH values much below 5.7, 5.8, and depending on the crop it is, they're not functioning well. Those fine fibrous roots that are responsible for the majority of the nutrient uptake aren't there. They're sawed off. They're more stubby, more malformed, and they're just not functioning like a root would in a pH above 6.2. So there's reasons besides low nutrients. So that's where it comes back. Soil sampling can be a great tool to diagnose that. Hey, my soil test P is 62, but I've got phosphorus deficiency. Well, dig some up, not pull them up, dig them up and look at your roots, see what's going on. Poke around with a soil probe or a penetrometer to see if you can find compaction. See if you can find something that's damaging those roots. But anyway, just going to finish up with a few pictures of nutrient deficiencies. So this is wheat. The dark, adequately fertilized with nitrogen. This one right here, real low nitrogen status, shorter, more yellow, more pale. Nitrogen in corn. You can see that's not as healthy as this stuff here on either side of it. Here's the classical symptoms. Have nice green leaf for this left corn leaf, more yellow, more yellow, more yellow. So nitrogen deficiency starts at that midrib and works towards the outer end of the leaves. Nitrogen deficiency in soybeans. Wait a second, nitrogen is made within the soybean plant. Why would I see nitrogen deficiency? Well, maybe you had a failure or not well nodulated soybeans, or I hadn't inoculated and there haven't been soybeans in this field in 10 years. Or maybe it's another environmental factor. Maybe these plants got waterlogged, which reduces the ability of the nitrogen to be fixed. So you can see nitrogen deficiency on soybeans. This is a picture of phosphorus deficiency in wheat. I had another one I forgot to include that showed the classical symptoms, but yeah, that's for real. That's a big difference. Here's that classic purpling in corn. This was not really early. This was a low nutrient status. This was ground that came out. It's one of the few times I've seen a single digit soil test P value, but the soil test P on this farm was a 3. So it was crazy that it even came up, but that's classical symptoms. Potassium, so regardless of the crop, it's going to start at the older edges, or the older leaves, the edges, and it's going to work in. So this is, well, that's not clover, that's alfalfa. Potassium, again, for clover. Here's that alfalfa, properly labeled. Potassium on soybean. So potassium on corn. Now look at the difference in these. Both of them kind of have that similar, that browning, the yellowing, but it manifests itself differently. Potassium is going to start at the outside and work towards the inside of the leaf. Nitrogen is going to start at the inside and then work towards the outside of the leaf. So they can be similar, but they kind of express themselves totally different. Potassium deficiency in tobacco, for those of you guys that still have a little tobacco in your county, same thing. It starts at the older leaves, which are going to be at the bottom, and it's going to work from the outside in. A lot of times you just have transient potassium deficiency in tobacco when it hits that exponential growth. This is a picture I took in Union County back in 2012. It was the first sulfur deficiency I ever saw in real life. It kind of can look like nitrogen. It's a yellowing close up. If you look at this field, there's an area right here, a little area here, a little area. There's no large areas. So if we had an acre, I'd be tickled with a half acre of ground that looked like this. We could do some response work, but I have not come across that yet. So keep me in mind if you do. So just some digital tools. Frank's got a lot of neat stuff, really useful stuff that I hope most of the agents are familiar with. But go to regulatory services, and I think I put the website up here on the next slide. But fertilizer calculators, you can look for line, calculate the proper rate, compare rates, and then Jordan Chocolate. There's also a manure calculator here. Jordan took it and kind of changed it a little bit. It has a few other things in there. So here's my supporting information. This CATS, Kentucky Ag Training School, it's something we started here at Princeton. It's for hands-on type training, but we're trying to post a lot of the videos. So if you want to see how to use a penetrometer in 3 to 5 minutes, we have those kind of clips, and we're going to try to start something real soon for agents and for all clientele. But we're thinking about calling it Coffee Cats. So in the time you can spend drinking a cup of coffee, you can learn some sort of management practice that can go back to your client. So another like 3 to 5 minute blurbs. Like for this, I might take that soil test depth example and just condense it to 3 to 5 minutes, so you don't have to watch the whole video. So all these links are live. You should be able to click on it and it'll take you where they go. And I believe that's all I have. I saved a few minutes for questions. I don't have to go anywhere for a few minutes, so we can talk till I think you guys are done with me, or I get hungry and need to go to lunch. So what's the best thing to do, Kevin? I see a few things here on my screen. Should I just try to read through these?
Well, the only one of them is a question. It's how would you say nutrient management looks for perennial crops, such as in orchards, lawns, and things like asparagus?
Okay, so alfalfa is a perennial crop. Hay is a perennial crop. So for the ones that I'm familiar with, the lawn, I'm going to focus in on, sample every couple years. Asparagus, I don't know much about that, but I'm pretty sure that's a high dollar crop. I would probably sample yearly for that. Orchards, I would defer to John Strang, but I would say every couple years. I know he said when they like to establish orchards, they try to fertilize or sample to 12 inches. I don't know enough about orchards to comment one way or the other on that. I would look at the recommendations that are in place, and I don't want to give someone a wrong answer, but I just don't feel very comfortable speaking to that other than follow the recommendations that are in place by the land grant university system. So in my mind, that would be John Strang, and he should have some information to do that. So where will this presentation be available, Kevin? Question to you.
We have 3 websites we're working on, and after I get done, I'll be contacting Craig and asking which one he wants me to put it on, because we have one site where you can download it, one site where you can't download it, and a YouTube channel. So I will send this out to everybody just to let them know where it's at after I know where I'm allowed to put it.
Okay, and if it matters, I'm happy to put it out wherever the most people can get this. There's nothing here that needs to be, protected.
Okay.
Okay. So what do you usually recommend to producers for low K applications or recommendations when the spreader buggies don't have that low of a setting? So I guess what the question is, I'm looking at a 30-pound application of K2O, which is going to be 50 pounds of muriate of potash per acre. So if we're at that real low rate, we're probably in a maintenance. We're probably not at a level that yield response is going to be seen, or a yield penalty is going to occur if we don't fertilize. My first thought is that the only fertilizer I need to put down? If no, then you're going to get your volume up a little bit more so you can hit that rate. About 30 pounds per acre is about the low end of the spreader capability. If you really feel like I want to put some fertilizer down, I would up the rate, I guess, a little bit, just to the lowest rate that I can function, and can go with that. But if I found this out recently, the reason that our lowest rate recommended was 30 is because at the time, back in the 70s when this was being developed, that's about as low as they could accurately apply per acre. So that's where that came in. So for the most part, if you're following our recommendations, you should be able to apply it. But that's my thought. Okay, so another question. Do we need to look at sulfur levels at all? Local dealer has been getting sulfur tested through their samples at Waters Lab. A majority of their samples have been coming back deficient. Crops would be mostly pastures, but some row crops. Okay, if Frank's still on, I'm going to let him help me after I start this. But the best of my understanding, the Malic 3 soil test extractant that we use for P and K is not adequate to extract sulfur. There's a big organic component that it does not get, so it just does not give a good representation of what is in that sample. So I am very hesitant to follow a Malic 3 soil test recommendation. Now, with that said, we talked about different mechanisms to apply fertility. We use a sufficient level of available nutrients based on research data. Well, like, I have not confirmed this, but I'm pretty sure doing the math, what they're doing is saying, okay, I want to grow 200 bushel corn. I know 200 bushel corn is going to remove X pounds of sulfur per bushel. So I need to add 15 pounds of sulfur to that crop so I know I have enough. So is that a good approach? Not really in my mind. Is it a bad approach? Well, there's worse approaches. I'm going to say 98% of the time, 99% of the time, that you're going to be adding a nutrient that is not needed. Yes, we have cleaned up our air. We are depositing a whole lot less sulfur than we did, but there's still a large amount of sulfur that is below that 4 to 6 inch sample that's being represented in the sample that goes to the core. Tissue sampling, I mean, I know you don't want to see a deficiency, but tissue sampling gives you a pretty good idea. I'm looking at some data now, and hopefully before long I'll be able to give a little bit more guidance. I've done a lot of survey work. I've done a lot of response work in areas that came back low, but I'm not seeing a response yet. Maybe that nitrogen to sulfur ratio in the tissue would be a good indication. I know if it's above 25 to 1, you're probably going to see some deficiencies. The data I have shows that break is somewhere around 18 to 19 to 1 for alfalfa, coming back deficient anyway. But Right now, we just don't have a good way. And Frank, if you have anything, oh, Frank's no longer there. Shoot. Well, that's my spill on sulfur. If you feel like you have it, you probably don't need to add the whole amount that would be removed because there's still sulfur. We never run out of, you never get to a soil test P of 0, or it's very unlikely that you would because you always have minerals dissolving. So the chances of us running out are slim, running out to the point that we have to add the whole amount that's going to be removed. So, I mean, I guess on a removal basis, if you want to be proactive, but I would back it off from a total removal. Maybe that's a little bit more than you were asking for, but that's my thought. So I see people are logging off. Can you guys do me a favor? Those that listened, shoot me an email, just 1 or 2 lines if you want, but maybe touching on some of these 3 to 5 minute topics that would be useful to you. Hey, this is how I read a soil test result, or this is what matters, or just anything. How do I use a penetrometer? So if you guys can shoot me some ideas over time, I'd like to, like I said, start developing a library of these 3 to 5 minute little tutorials. It'll be pretty similar to this, and post them there to Kat's website. Do we have any more questions?
I don't see any more questions. I just want to give them a couple of wrap-up notes, though. This was the session that was originally scheduled for March 24th in KERS. So to get the credit, you need to sign up for the March 24th session in KERS for today. And when are we going to do the session 2? Wednesday next week?
I would like to do it same time, same channel next week if we can. I'm available. I'm not allowed to go to Tennessee or Indiana or Ohio, so I'll be in my office.
Then I'll send it out scheduled for next week.
Okay, well, thank you all for coming, and make sure to give me some questions to discuss. Thank you, and thank you, Kevin.
You're welcome. Everybody have a good day.
You too. Bye.